like to explain what is conservation of angular momentum.
Conservation of angular momentum means no external torque acts on a system. The total angular momentum of a system about a rotation axis is remain constant. The formula is total L initial equal to total L final. This means if you decrease radius, decrease moment inertia, you increase the rotational speed. Thank you.
Let's see example number 1. Figure 1 shows three 0.05 kg weights attached to light rods. The rotation is rotated about z-axis at angular speed 65 radian per second. Calculate the moment of inertia of the system about the axis of rotation. B. Mass to be added at B to reduce the angular speed to 15 radian per second. Okay, let's answer question A. As we know, the equation for moment of inertia is equal to I equal to mr squared, which is m if mass in unit kg and r is radius in unit meter. So for this question, moment of inertia of the system is the total arc, the moment of inertia at x-axis and y-axis. After that, by using all the information given, we just need to substitute into the formula. For moment of inertia at x-axis is 0.05 kg times 0.03 squared meter squared plus 0.05 kg times 0.04 meter squared for moment of inertia at y-axis. So the answer we will get 1.25 times 10 power of negative 4 in unit kilogram meter squared. That's all. Okay, for question B, we need to find the mass that can be added to reduce the angular momentum to 15 radian per second. So for this question, we need to use formula conservation of angular momentum. The formula is the initial angular momentum is equal to final angular momentum. For this question, we already know the initial moment of inertia in A, which is 1.25 times 10 power negative 4. So now we just need to find the final moment of inertia. Final moment of inertia is equal to 1.25 times 10 power negative 4 plus 0.05 meter squared m. M is the mass that we need to find. So we substitute the information that we have into the formula. First, we have the initial angular momentum, which is 1.25 times 10 power negative 4 times 65. 65 is 4 omega. (1.25) times 10 power of negative 4 times 65 is equal to 1.25 times 10 power negative 4 plus 2.5 times 10 negative 3 m. This is the final moment inertia that we find at here. So we times it with 15 radian per second. So after that, the answer would be 8.125 times 10 negative 3 is equal to 1.875 times 10 negative 3 plus 0.0375 m. After that, we will get 0.0375 is equal to 8.125 times 10 negative 3 minus 1.875 times 10 negative 3. After that, we find m, and the answer we will get m is equal to 0.1667 kilogram. Okay, for question C, first of all, let's take out all the information from the question. First, we know the mass of the boy is 50 kilogram, standing at the edge of the table with radius 4 meter. The angular velocity of the boy is 0.5 radian per second. Secondly, we know the radius of the boy decreased from 4 meter to 3 meter. But we must find the angular velocity. And then we have the moment of inertia of the platform is 1000 kilogram meter square. Next, for this question, we also need to use angular conservation of angular momentum formula. So we substitute all the information given into the formula. So we will get 1000 plus 50 times 4 squared times 0.5 radian per second. And for final angular momentum is 1000 times 50 times 3 square times omega, which is we need to find. So after that, we will get 900 is equal to 1450 omega. So we divide 900 with 1450 and we will get 0.62 radian per second. Thank you. Yes.
you.